Attracting tomorrow. TDK.
Okay, one of the most commonly asked questions for TDK's Faraday chip-embedded micro-point-of loads is, do we have standard evaluation boards for the FS1406, the FS1404, and the FS1403? The answer is yes. It turns out that even though we have different output versions of the FS1406 and the 1404 and the 1403, we actually have standard evaluation boards for all three series. For the 1406, the standard eval board is the EV1406, the 1800A. This stands for 1.8 volts. So the standard eval board for the 1406 is set at 1.8 volts. For the 1404 and the 1403, the standard eval board is 3.3 volts and 5 volt respectively. And here are the actual eval board numbers that you can see here, ordering codes and the output voltage and range. In addition to this, for customers who also want to program the output voltage as well, there is an additional TDK micro point of load dongle. This is an optional, of course, and we will demonstrate that later in the video of how to use the TDK micro point of load dongle if you want to program the output voltage and test your design. The next question that comes as well, if you do decide to program the device, is how can you program the output voltage via I2C? As you can see in the picture here, there are I2C ports on the SCL and enable and the SDA pins, respectively pins 1, 3, and 4. So typically you would just get the eval board. In this case, the standard eval board is 1.8. You would use the I2C interface, and you can actually trim the output voltage plus or minus 5 millivolts with any of these devices. There's also, as I mentioned earlier, the programming dongle, which can be ordered, and the control center GUI software. At the time of this video, the current revision of the control center is revision 1.4. This is also downloadable on our website, and we mentioned already the website at www.tdk.com/point-of-load. We will show you that website here in a second. And then we mentioned the eval boards already, so let's take a look at the website. Here's the actual TDK website where you can download the GUI software as also the GUI user's manual. So let's take a look at the GUI user's manual called Faraday. This is the actual Faraday graphic user manual, and with this manual it's quite easy to set it up. We'll be demonstrating some of these features in the video: the system requirements, the hardware requirements, and then how to basically connect to the board. A nice step-by-step feature for each of the different registers that are inside the device. The register map is also available here as well on the website, and it shows you how to connect your dongle to your board and to your eval board and to your computer, your graphic user interface. So that's the Faraday graphics user interface user's guideline, user's manual. Also on the website you'll find for each of the eval boards in this section here called Power Design Demo Board User's Guide. So for the 1.8 version of the FS1406 eval and the 3.3 and the 5 volt for the 1404 and 1403 eval board, you can actually view the Power Design User's Guide that we actually take actual results of each of these eval boards. Here's an example of, in fact, the FS1406 at a 12 volt input, 1.8 volt output at 6 amps. And it's quite a comprehensive design user's guide. It provides you with the actual connections, the board features, the input, the output, as well as the input capacitor and the output capacitors. the connection diagrams of the board as well, where you can verify many of the measurements, as well as the layout of the Evo board and its positions. It even contains extra capacitors slots if you want to add in more output capacitors in case you would like to reduce any DC or AC ripple. A very simple schematic which shows you the exact schematic as well as where the test leads are located, the build of materials, and then of course all the performance waveforms, the startup, the soft turn off, the shutdown enables, pre-bias, the switching frequency and how that looks on the scope, the output ripple at different load conditions, as well as the transients conditions as well for the step load, and then finally efficiency, power loss, thermals as well to show you the thermals. So a common question is how much did it rise from room temperature, and then load regulation, and then accuracy. So this is also available on our website as well. Okay, I wanted to do a simple video today of our FS1406 evaluation board, and this particular board is here centered to the right. It's actually centered at about 1.8 volts. Just want to kind of zoom in so you can kind of see it. There are two different types of EVO boards we have. This one shows the small form factor of the power module and a spacing of about 7.5, 8.5 millimeters. This includes the power module, which has the inductor on the top of it in the center, and the external output capacitors as well. So complete solution for 6 amps with the FS1403 in this form factor. And I just want to show a quick setup here. We've got our power supplies powered in already here to the right. So you connect your VCC and your ground lead there. And since it's already powered up, it's quite simple. We're just going to do a quick measurement here of the outputs. And you can actually measure it right on the board. And we'll plug in the power supply. And there you go. 1.799 volts. Very simple demonstration for the FS 1406 at 6 amps. Now we're going to go ahead and actually attach the dongle for a more advanced demonstration. This is actually the Faraday control center dongle. It's got the USB cable here to the right, which you would attach to your computer to access the control center GUI, and then the connector that goes on to the actual eval board. So let's go ahead and set this up very quickly for a fast demo of the control center GUI. And what we're going to do is we're going to change now this 1.8 volts to another voltage. We're going to demonstrate some of the simple I2C features. There's also a ground lead here. Signal. There's the ground lead there. So I'd go to my board and attach into the ground right about there. And that should do it. Alright. Got my pig board there. There you are. So we've actually set up now this for demonstration, and we're going to go ahead and launch our control center GUI. Now if you look at my screen, you'll actually see the control center shortcut GUI icon next to the surfer, and we're going to go ahead and launch this GUI. I'm going to put it right there in the middle of the screen. And the first thing you're going to want to do is to connect to the board. So there's under File, and you go to Connect. You would hit Connect. What's going to happen here under Status, this should turn on within 3 seconds. There you go. So it went from status to green to power good. So now we know we're connected to the board. And you'll notice right away, as you look at the GUI, it actually read the trimming register at 1.76. So it's actually read the internal register that the device was trimmed to. Now there's a natural offset of the DAC inside the device. So what's nice about this GUI. So even though it reads at 1.8, you still have the ability to trim up and down, as you can see here, plus or minus 5 millivolts. So what we're going to do in this particular example is we're going to trim this down to 1.2 volts. I'm going to go ahead and just do some major jumping here with the GUI. I'm going to come in maybe just a tad under here, and I'm going to hit right. So you hit right, and as you look at my screen, you see that it sent actually via the I2C dongle to the board now, and you can now see reading at 1.195. That's actually pretty close to 1.2. I'm going to go ahead and show you back on the GUI. Let's trim up a little bit to see what happens. Do a right again. Now you can see dead on at 1.2 volts. So there's a little bit of offset in there on the internal DAX of the device, but you can see you can do closed loop trim plus or minus 5 millivolts, now at 1.2 volts. Quite a simple demonstration of how to use the dongle and the eval board to trim your device by plus or minus 5 millivolts. A couple other housekeeping functions I wanted to show you. The ability now, as you look at the GUI, to do soft start rate, fast or slow. You can see the actual values in the data sheet. You also have, as you look at the power grid thresholds, you can program different power grid thresholds to target. There's also an overcurrent protection. In this particular case, it looks like it was set to 4 amps, and you can actually go higher. Here also is the default address. This is called the base address register. So this actual EVA board is at base address X08 hex. So it's actually at 8 hex as the base address. And in your schematic, as we'll show a little bit later, there is the ability to add external resistors to add to the base address with a slave resistor. In this case, if you look down here at the device address, you could add an external resistor on the schematic and add multiple devices on I2C, and this is where you would go here to actually go to different slave addresses based upon the base address of the external resistor. Anyway, just a quick demonstration of the FS1406 eval board and how easy it is to work with.
Attracting tomorrow. TDK.